Hi folks, today I bring you a VFD driver reference ML9228 from the brand OK. It is implemented in the car radio panel with a CD player, as it has a space on the PCB for the CD input. It is a driver with the direct control of the 82 segments, and each of the three possible grids can be accessed individually. This results in the total of the 246 segments. We can use the command mode to define the M0, M1 and M2 equal to 000 to write to all the three grids simultaneously. The method is very clear in the driver datasheet, and I use this process to write to the same at the same time for the three grids in the process to find the segments. The driver feature a 5x6 key matrix and has a push button and a quadrature knob as input mode. What is what I liking about this driver is the fact that it works with a voltage between the 8 and 18.5 volts positives in relation to the GND to polarize the grid segments. We have already discussed several VFD drivers that receive a positive voltage to control the grids and segments, but is not the most common. The most normal things for the grids and segments voltage to be a negative in relation to the GND. So I like this detail as it results in the operation with only 2 voltage as a power source. In this case, 3.3 volts or 5 volts for the logic voltage and the filaments. To the grids and segments, a voltage of the 18.5. Here I'm using the 5 volts DC as a logic VCC and the VFD filaments, since I'm using the Arduino platform to provide the pins of the data, clock and the chip enable, while maintaining the common reference of the Arduino GND common to my two power sources. As usual, I used a function to identify the segment numbers. It was a little more unusual as the byte multiples result in the 88 bits and we have to send a maximum of 85. In this function called to define the last 5 bits, I added a variable to receive the number of the bits as to be sent. I like the fact the driver, when started by default, remains at a low dimmer value, which prevents any visualization. For this reason, the first 3 lines of the loop are to set it to maximum, so as not to mislead by thinking the panel does not work, when it is just a lack of the brightness. To find the segments, I use a little button with a trigger every time it's pressed and skip from the segment into the next segment. The process is very easy, but I need alert in this VFD. We have the shared grids. You have the grid 3, grid 1, grid 3 again, grid 2, this is independent, and again the grid 1. By this reason, every time I press the button, I skip from segment to the segment, but this is segment 1, 2, 3, 4, 5, 6, 7. And here you can see the segment 7 is like highlighted in the three grids. The pins to connect the panel are present in this block. You can see the connection from the Arduino, the pin 8, 9, 10, data, clock, chip enable. At this point you have the GND. This is very important. You must keep this reference connected to the both power sources. The GND from the both powers, 5 volts logic and voltage to the segments. I use the 1K resistors to protect, but it's not necessary. The pins coming from the block have the same names. The reset is internal connected to the VCC, is not necessary force it. The GND from the voltage to the segments is chanted or is connected internal to the logical GND, and that's all.